Hello everyone, this is Ashwin here. In this video we are going to see how to use machine learning with PySpark. So we are going to see end-to-end analysis, how to use PySpark for loan prediction project. We already done this project with normal method. We already done this project in a detailed way with visualizations and everything. If you want to see that project, you can click on the right top corner of this video. I have explained everything from analysis and creating new features and everything. So in this project also we will do the same, but we won't be touching on visualization. Apart from that, we will covering everything from end to end. So before jumping into the project, we have to install PySpark into your system. So the first step you have to install is Java. So I will just give you the instructions here itself. Installing PySpark. First step is to install Java. Second one is install Apache Spark with Hadoop. So Java you can install from OpenJDK, so that will be easier. And for the Apache Spark with the Hadoop, you can go to this website. So this is the Apache Spark website. If you just type on Apache Spark with Hadoop, you can directly go into this link. So this is the Spark version I am using, 3.3.2. So pre-built for Apache Hadoop. And later just download this file and extract it in some folder. I extracted in my C drive. So this is my C drive I have extracted here. So this is the Spark home folder. After this, you have to set some environment variables. So the first one is Java home. So here you can see I have set Java home, and apart from that you have to set Spark home. These are the two environment variables you have to set. And after that, this is the path. Just add the Java home and Spark home with the bin folder. So this is should be added inside the path. So this is the basic setup. Once this is done, so once these two things are done, I will also add set environment variables, and after this you have to install pip install PySpark for the module in the Python package. So I already done these things including the installation. So I'll directly go into the project now. Before that, I'll also explain why we need PySpark. When we are dealing with normal approach like using pandas and traditionally going with our analysis, we are not utilizing the full power of our hardware. Let's say if we have like 12 cores, means we are not using the 12 cores as it is. Using PySpark, you can scale your solution using like when you are working for some companies, you can deploy this particular project into some clusters or machines with like multiple cores. It will utilize all the cores, and it will definitely speed up your process. So that is the main advantage. So especially you will be dealing with PySpark when you are going into production for some company. Now let's import few modules. So import PySpark. So this is the main one. From PySpark.SQL import Spark session. So for everything we will be creating a session first, and import PySpark.SQL.functions. We will be using a lot of functions. So all the functions are available in this module. So I'll just call it as F, and we will call all the functions from here. And lastly, of our main module, that is pandas as PD. So we are not going to like load the CSV using pandas. Only for particular functionality we could use pandas. And apart from that, even if you are working with pandas, you can change the data frame to anytime to PySpark data frame. So it is like interchangeable. So but PySpark will be much more faster than pandas. Let's import it. I guess we will also import warnings. Warnings dot filter warnings ignore. Okay, now it is much cleaner. Let's initialize the session and load the dataset. First I will initialize the session, load the dataset. Before that, initialize the session. So Spark equals Spark session dot builder dot app name. I'll just set some this project itself, loan prediction. You can give any name you want, get or create. So if some session is already created with this particular name, means it will retrieve that session. So that's why we are using this function. So this will initialize the session in Spark. Let's run this. So it is taking some time at the first only. After that it will be much smoother. Okay, now the session is initialized without any error. So we can move to the next step. Now df equals spark dot read dot csv. So based on the file you can change the format. I have loan prediction dataset. We have headers in this particular CSV. So I will say header equals true, and separator, this is optional. It's already like CSV. If you have any other format, let's say semicolon or tab means, so you have to specify the separator here. And infer schema equals true. So if the dataset have some schema information means represents to like a particular data type, it will get that as well. Now df dot show, I will mention 5. Usually df dot head will display the top 5. Show will display more rows, so that's why I am specifying 5. Okay, now the dataset is loaded. This is the heading, so it's not like that much representable in terms of UI. Usually in pandas we will get a table, and you can usually scroll the table, and it will be easy to use, but when you are dealing with like consoles and everything, this printing format will be much more suitable. And if it's a small data set, means you could have seen everything in a clear way, but here the number of columns are higher, so you can see the column names here until the loan status, and this is the first row including this one. We also have a couple of null values. That's why I have chosen this data set to cover all aspects how to use PySpark. So for detailed information about the dataset, again you can check that previous video I have already made. Now let's display some basic information. df dot print schema. So here you can see all the column names with the data type. So here we have string, double, and we also have like nullable equals true, because this data set contains like many null values. We will be filling those null values very quickly. Okay, again df dot d types. So when you want the column and the particular data type, you can use this. It will give you a tuple of column and the data type. So this is the basic analysis. Let's dig deeper. Data analysis. Here we are not going to use like visualization. We will be displaying few information with tabular structure. Let's see some of them. Display count based on loan status. Here the objective for us to predict the loan status, whether it will be accepted or not. This is a classification problem. Let's see how many samples we have. Df dot group by. So most of the things we will be dealing with SQL based queries. So loan status, okay, it's not suggesting very well. Loan status dot count dot show. So here you can see the count of yes, it is 422, and the count of no is 192. This is like a basic analysis. Let's do something more. Df dot select of, I will get credit history and loan status. I'm going to get the average of credit history based on that particular output class. So for simpler way, you can just easily copy paste. Again, group by of loan status. Oh, it's not even suggesting like normally. Group by aggregation of f dot average of credit history. I'm just taking the average of credit history. It's currently a integer, so we can do average of that. Average of credit history dot show. So here we can see that the people who got loan has higher credit history. That is most of the people have some credit history. Usually the credit history variable will have 0 or 1. So based on the average, majority of the person have like credit history, and only half the people have like doesn't have credit history in the negative class. Let's also do another analysis, like how many people are male and female based on the gender. So df dot select of gender loan status dot group by of loan status, okay, loan status and gender dot count dot show. So here we can see some null values. If you remove some null values, means it will only show yes no, male female, like all the combinations of like loan status. So here based on the count, like majority of the applicants are male, only few applicants are female, both in the positive and negative class if you compare it. So it's like 1/4 of them are female from compared to the male count. Let's create some correlation matrix. Correlation matrix. So we have already done this in a simpler way with pandas. So we will also do the same here. I'll change it to markdown now. So first we will consider the columns which we need correlation only on the numerical variables. So for this I will again print the schema, so it will be easier for us to like copy paste. Now columns equals, I will take applicant income, co-applicant income, co-applicant income, loan amount, term. Every variable is like uneven here. They should follow some common format, so it will be easy for us to create new columns as well. So lastly, I will also consider credit history. So these are the columns I'm going to consider for now. I'm going to create an empty data frame. So correlation plot equals, or else I will just have core df pd dot data frame for column in columns, column in columns, core equals an empty list. Again, we have to like iterate the columns because this is like a n cross n matrix. Maybe I will have this as like I, and for j in columns, core dot append round of df dot stat of core I comma j, and I will round off the decimal points to 2. So once everything is done, I will concatenate with this data frame we have created. So core df equals pd dot concat of core df comma pd dot series of correlation, and axis equals 1. Now core df dot columns equals the columns we have created. Only 5 columns we have created. I'm just appending in this data frame, and after that core df dot insert 0 empty character and columns, and core df dot set index of empty character. Now run this. Now we have got our correlation matrix. If you don't do this and just displaying the correlation matrix, you will be getting like this. So we don't want to like do that. We want like a good matrix. That's why we are doing this step, and run this. Now we got a good correlation matrix. Here we can see some high correlation between loan amount and the applicant income. Apart from that, I'm not seeing that much of an impact in this correlation matrix. So all the variables are like less impactful. Even co-applicant income have like slight positive correlation on the loan amount. So these two variables have some impact on the loan amount variable. So that is on the correlation matrix part. Apart from these operation, you can also do some analysis with using this multiple operation. We can use aggregation, count. It depends on your creativity. You can do the analysis in practically many different ways. Let's do analysis using different operation. We can perform SQL operations. So let's consider this whole thing as a table, like a SQL table. You can put some queries similar to how you write SQL, and you can get the results for that. So people who are familiar with SQL, this will be very easier for them. Okay, first import the modules PySpark .sql as Spark SQL. Now df dot create or replace temp view. So I'm just converting this data frame to call it as like a table. This is like a alias. You can have different table name as well. Now let's do some basic SQL query. Display top rows from the table. So Spark dot SQL of select star from table. So this is the query. Let's display that. So now you can see it's showing like only top 20 rows, and it is displaying all the data. You can also limit a few values if you set some limit here. Let's see whether it is working. Limit 5. Now it is showing only the top 5 SQL values. So you can mention some column names if you want to like do some filtration. Everything is possible using SQL, whatever you have learned. Now let's do a simple analysis. Spark.sql select count of star from table where credit history equals 1. So it will just display out the credit history. We could display some other thing, maybe loan ID. I'm just getting loan. Each time it's just giving that dataset name alone. Loan ID from the table where credit history is 1. Dot show. Now it is giving us some loan IDs where the applicant have credit history equals 1. So this is the simple commands, and you can always combine multiple operations like group by and everything, and you can get all the information from using SQL. Now that we have covered doing some analysis, let's do some data pre-processing, data cleaning. First we will display the null values in that particular columns. Display null values. So usually in the pandas data frame it will be very straightforward, but here this will be much more complicated. df.select of a list f.count of f.win f.call of c dot is null comma c dot alias of c for c in df dot columns, and finally I will display the result. So what I'm doing is I'm iterating through the column names, and for accessing the column we have to use this call function, and this is the column name, and I'm getting the column and checking whether it is null, and I'm giving some ideas to display in that table with the same column name, and I'm also like doing the count. So when it is like true, I'm just counting that values. Finally I'm displaying all the results. Now you can see for the corresponding columns we have the number of null values. So credit history have like 50, gender have like 13, married have 3 null values, and self-employed have 32. So like this, we have to fill all the null values. We can fill some of the numerical values using mean, and for categorical values we will be using mode. That is like a simple pre-processing. If you want to know complete data cleaning and how to pre-process the data in an efficient way, you can click on the right top corner of this video to see that in detail. Now this is done. Get mean value of column. Now we are going to get the mean value of one variable, like one column. So df dot select of f dot mean. As I said, these functions have like pretty much all the functions we need. Df of loan amount dot collect. So this will give you the mean like this. You have to get this number alone. So for this we will use double index. Now we got that mean of this particular column. So let's do this for a couple of columns and do it in a loop. Before that, I will also show you like how to fill the null value using this mean. So I will say df equals df dot na dot fill. I will fill it with this mean value that I have stored before, and in the column loan amount. So this will fill the null value, and for getting mean, this is the function. For mode, we don't have like any particular function, so we have to create our own. Get mode value of column. This will be fill null value. Now df dot group by of gender dot count dot order by. Okay, it's not suggesting. Order by of count ascending equals false dot first. Let's run this once. So what I'm currently doing is I'm first grouping by gender and getting the count. So we will know which particular value have like higher count. So for that I am sorting it by descending order. So the higher count value will be on the first row, and I am getting first using this. So this is the first row. You will be getting this count. We just need the value, so I will just say 0. Now we have got our most common value in the data set. Now this is done. Let's do it for all the columns. Fill null values for all the columns. First I will be getting numerical variables, numerical calls. So as we already seen, loan amount is there, and loan amount term is there. So here you can see these applicant income and co-applicant income doesn't have any null value, so only these two are there. And categorical calls equals gender, married, dependents, self-employed, credit history. Even though it's an integer, it's just like a binary categorical value, so that's why I'm considering this as like a categorical value. Okay, now this is done. Let's fill those values. For call in numerical calls, main equals df dot select of f dot mean, df of call dot collect. So we already seen this here. I'm just replacing the loan amount with the column because we are iterating, and after that we will just fill the mean like this. So instead of the loan amount, we will have the column. Run this. Now this will be the missing values will be filled. We have to do the same for categorical columns. For call in categorical calls, we have to find the mode. So I'll just copy this. So mode equals, instead of gender, we will have this column from the list, and count remains the same. And again we will fill the missing value like this. So instead of mean, we will use mode. Okay, now that is done. Let's run this. Okay, now we have filled null values for all the columns. Let's check it again. Now you can see all the null values have been filled. So this is good. So as we did in the previous video, we will be creating a new column combining the applicant income and co-applicant income as a total income. We will be just adding these two together. So to do that, df equals df dot with column, the new column name, I will have it as total income, and inside that, to get those columns, I already said f dot call of total column, applicant income. It's not suggesting here as well, so I'll just copy and paste it. Applicant income plus f dot call of co-applicant income. Now this will create a new column adding these two together. Let's display it. Df of show. Now you can see if you add these together, it remains the same, but if you add these together, it's 6091. So this is working fine without any issues. If you want to do some other operation, means you could always pass it to some function and get the result, and you can create this column like this. So that's covered that. Let's also see how to do find and replace. We have the loan status, which is the output variable. We'll be converting that to numerical value. So this one, create new feature column, and here how to find and replace values. So df equals df dot with column. So here you have to specify the column you want to change. That will be loan status, and here f dot when df of loan status equals yes. So when you are considering when the loan status is y, we will be replacing it 1 dot otherwise 0. So this is like a if else condition in a single line. So I'm just using this when function to replace when the column value is equal to y, I'll be replacing that with 1. If it is no, means it will go to the else path, that is otherwise it will be 0. I think one bracket we have missed. Okay, I think okay, now it is clear. So this otherwise will be coming with this when function. Now this is done. Let's again show the values. Now you can see yes and no is changed to 1 and 0. So you have to anyway change this to numerical value in order to apply it to the model. This is one way you could do. I'm just trying to cover all the functions that we can possibly cover with this data set. So now the data pre-processing steps are completed. Let's do feature engineering. So we have to create some pipeline in order to transform the data into a applicable format, because we do have categories like this gender, education. So we have to do one hot encoding for that. So I will explain everything in the feature engineering step. Feature engineering. Okay, let's leave some cells. Now for easy process, I will print the schema so we can copy and paste the modules very quickly. So from PySpark.ml.feature import vector assembler. So this is main for all the project, and one hot encoder if you have categorical values like this, and string indexer. This is for first we will index that string like categorical values, and after that we will be applying one hot encoder on that. For other features like integer, double, we will be directly using this vector assembler. So for all this I'll be integrating everything into a single pipeline. So this will just pass it to one function to another. From PySpark.ml import pipeline. This will be capital P. Okay, now that we have run that, let's identify the categorical columns and numerical columns. So first categorical columns equals, so loan ID we will be dropping that in the end. We don't need that, so we won't include that in the feature. So gender is a category, and married, dependence, education, self-employed, and we have property area. So these are the categorical values. You could also consider credit history as a category if you want. I think it's already like 1 or 0, so it is fine. We can just leave it as it is. Next one is numerical columns. Numerical columns. So first one is applicant income. Co-applicant income. Loan amount term. Loan amount term. And credit history. Anything else? Yeah, total income is there. Okay, these are the categorical columns and numerical columns. Now first index the string columns. So I will create some multiple indexers in a list. So string indexer of input call equals call, and output call, okay, this should be inside, and output call equals, I will do some formatting here, 0 underscore index dot format of column, and to iterate the column, for column in categorical columns. So this will iterate over the columns, and we are using string indexer to convert this column and indexing that. So this is for indexers, and here encode the indexed values. So for this I'm gonna use encoders. Encoders equals one hot encoder of drop last. So we usually have this drop last function in most of the one hot encoding techniques, because even if you take all the columns, if you drop the last column, the model will learn better. So that's why we are using this. You can learn more about this one hot encoding and label encoding on the internet. And again, input call equals indexer dot get output call. So this is for input column, and for output column, output call equals, again we will do the same formatting, 0 encoded dot format of indexer dot get output call. Now we have to iterate through the index. I can iterate in the next step. For indexer in indexers, okay, this should cover up everything. So now we have indexed the column, and we also done the encoding part. Now we will be creating the input columns, appending all these things. So input columns equals, so we need the encoded outputs, right? So for encoder in encoders, here encoder dot get output call. First I'm initializing with the encoded columns, and after that we do have the numerical columns, right? I'll just append it together. So what I will do is plus numerical columns. I'm just appending together in a single line. So this will contain all the input columns. So this will contain the categorical column output, and this will contain the numerical column values. Now that is done, vectorize the encoded values. Now we will be using this input column to get the vector features. So assembler equals vector assembler, input calls equals input columns, output call equals feature. So all the inputs will be combined, and we will be getting all the values in this feature column. So this is the this will be used as a input in the machine learning model. Let's run this. Now we have already imported the pipeline. Let's initialize it here. Pipeline equals pipeline of stages equals, first we have the indexes plus encoders plus assembler. Create the pipeline to transform the data. If you already created some machine learning model, means you can add it to the stage and directly fit the model. But here I am just converting or doing transformation on the data level. We are not touching the model yet, so it will be clear for us. We don't want any confusion here. Now that the pipeline is set to transform the data, let's do that. I will call it as data model equals pipeline dot fit with the data. Everything will be done quickly because it is using all the cores in my machine. Now that fitting is completed, we could transform the data. So that will be transformed df equals model dot transform of df. So usually we have like fit transform in various transformations we have seen before, like PCA and everything, but here we have like only fit, and after that we could do the transform like this. Let's see the results. Run this once. Okay, that is data model. Now that is done. Transform df dot show 1. Now we could see so many things. So this is the actual input we got before, and after that we have the index we have created. After the index we have the encoded columns. All the encoded columns will be appended to the feature. So these are like transformed in stage by stage. In the assembler everything will be concatenated, and this is the feature we are having, the last step. So this will contain like all the features. So here I'm going to take the feature column and the loan status column, which is the input and the output. Get input feature column, input feature and output columns. Transform df equals transform df dot select of the list of columns we need. That will be feature comma loan status. Okay, now that is done. Split the data for train and test. So train data test data equals transform df dot random split of we can do 80-20 split, 80 0.8 and 0.2. So usually we define some random state, but here the variable is called seed. So give it some number, so we will get the same split every time we run this, and let's display the train data. So now you can see we have like all the features here as the input and the loan status as the output. Now the feature engineering is done. All the data and everything is ready. Let's go for model training and testing. So here I'm going to import logistic regression. So from PySpark.ml.classification import logistic regression. So this is the basic model, and LR equals logistic regression of feature call. Here you have to pass the feature column and label call the label column, that is loan status. We usually define everything in the data frame itself, but here this is different. You have to specify the columns here, and after this we can create our model. LR model equals LR dot fit of train data. Let's run this. Let's leave some space as well. Everything will be done very quickly. Even the data set is very small, and it will use like all the cores in our CPU. Now the model is trained. Let's do the prediction. Predict on test data. Before that, I will also import another module. Maybe I can import everything at the start, so it will be easier. Logistic regression, I also have to import random forest classifier. For evaluation metric, I will be using binary classification evaluator. So from PySpark dot ml dot evaluation import binary classification evaluator. Now this is done. Let's do the predictions. Predictions equals LR model dot transform of test data. So this will give you the predictions based on the test data input. So let's see what is we have in the predictions. Now you can see this is the input and the output of the test data, and this is the prediction we have, like raw prediction, the probability, and this is the actual prediction. So you can see everything is like 1 and some of them are 0. It is like correctly predicting those things. So we have around like 80% accuracy for logistic regression. So that is pretty decent. Now that is done, maybe we will just display only 5 rows for the purpose. I will have the same here, and we will create the metric that will be AUC binary classification evaluator dot set label column. Here the label column is loan status, so we will set that. Now print AUC. Okay, AUC str of AUC dot evaluate of predictions. Run this. So we are getting around like 77% accuracy using logistic regression. Last time I got more. I'm not sure like why. I think we could change this credit history. We will just move the credit history to categorical value. Now let's rerun everything once again. So now it increased to like 78. So that is actual categorical value. So just by giving it as a different feature, this is how the impact in the model. So whatever you are doing, like 80% of the time you will be concentrating on the data, rest 20% time we will be like working on the model training and testing. So this is the impact just by changing one feature from numerical to category. So this is for logistic regression. Let's do it for random forest. Rf equals random forest classifier. We will have the same feature call and label call here as well. And rf model equals rf dot fit train data. See, the model is trained very quickly. Now let's do the predictions again. Everything remains the same. This will be rf. Let's run this. Okay, now we got around like 82 percentage of AUC, which is pretty good. I think even we didn't get this much improvement while doing in the previous video. So this is definitely a good improvement. So that's pretty much it, guys. We have seen end-to-end analysis and how to perform every step using PySpark. It will be like quite different how we are dealing with this. Usually you could just easily convert Spark data frame to pandas like this. We have the df, right? Df dot to pandas. So this will give you the pandas data frame. I will say pandas df equals df dot to pandas and pandas df dot head. See, now we have got the values in pandas. So this is how you can convert the Spark data frame to pandas data frame. Maybe I'll just move this to the top. So you can also convert this pandas data frame to Spark data frame using spark.create data frame function. And that's pretty much it, guys. We have done end-to-end analysis of loan prediction project and got 82% AUC. And we have seen different varieties of function for the data analysis, and we also seen how to do it in SQL. And we also done proper data cleaning. Even at the base level, we have done it. And we also seen how we can do feature engineering and how to convert this to features that Spark can accept. And after everything, we have trained the model. So Spark does not support like all the machine learning algorithms, but it supports the major ones, which can use the parallel processing power of the CPU. So we could see majority of the modules here, and we could also do different types of evaluation metrics. If you have any queries in this video, please leave a comment below. I will definitely answer that. And if you want to know more about PySpark and dealing with machine learning means, just leave a comment below. I will try to come up with new projects and covering more tutorial on this particular topic. Apart from this, if you like this video, hit the like button and don't forget to subscribe the channel for more videos like this. See you guys in the next video.